Okay, here we go. Unit 3, Lesson 7, reasoning about similarity with transformation. So let's describe similar triangles. 7.1, notice and wonder nested triangles. What do you notice? What do you wonder? So on this one, I would want you to write notice and then underline and then wonder over here. So let's see. I notice small triangle and a big triangle. So small triangle, ADE, bigger triangle, ABC. What else do I notice? Looks like A doesn't move. So it looks like A is shared by both. What else do I notice? I noticed 3 compared to 12. The scale factor of 4. I noticed 5 compared to 20. So that's a scale factor of 4. And I noticed 4 compared to 16, which is a scale factor of 4. So I see a scale factor of 4 from ADE to triangle ABC. What else could we talk about here? So the sides are in the same proportion. What do I wonder? I wonder if, so I know angle A is congruent to both triangles. I wonder, does angle D, is it congruent to angle B? I want to know if angle AED, so is AED congruent to ACD? What else do I want to know? I want to know is triangle ABC a dilation of triangle AED? What else do I wonder? Let's see. Are they both right triangles? Right triangles? So is this, in other words, is this a right angle? And if so, how could we figure it out? So are they both right triangles? How could we find the angles? So how could we find the angle measures? Okay. Yeah, I could answer all these questions right now. This should just say similar, not congruent. But I could answer all those questions right now, but I'm not going to. But anyway, it's designed to give you a glimpse into what's to come. So notice and wonder. All right. Stretched or distorted triangles. Sketch 2 triangles with all pairs of corresponding angles congruent and with all pairs of corresponding side lengths in the same proportion. Okay. See how we could do this. Let's see if I can do this again. 3, 4, 5, 6. Yeah, this could work. Okay, so we're gonna work over here. So I gotta sketch 2 triangles with all pairs of corresponding angles congruent, all pairs of corresponding side lengths in the same proportion. All right, so this one I'm gonna go 3, 4. This should be 5. All right, it is. Okay, so I got a 90 degree. We got a 3, we got a 4, we got a 5. All right. Now this angle is, let's find out. Be 40, 55, 45. Let's triple check here. About 55, 45. Let me just run some trig here. All right, so there's 1, there's 3, 4, 5. We're gonna go 6, 6, 8, 10. 6, 8, right there, and 10. Okay, so this one is 6, 8, and 10. Okay, so we're gonna say A, B, C, D, E, F. Okay, so here we go. Two triangles, all pairs of corresponding angles congruent. All pairs of corresponding side lengths in the same proportion. Label your triangles A, B, C, D, E, F, so that angle A, 2 marks, is congruent to D, angle B is congruent to E, and angle C is congruent to F. All right, label each side with its length, 3, 4, 5, 6, 8, 10. Okay, next up, do the two triangles you drew fit the definition of similar? Explain your reasoning. So similar means a series of rigid motions and dilations takes one to the other. Let's see. So we got to figure out if there's a series of rigid motions and dilations taking one to the other. All right, so we got A, B, and C. So here we go. A, B, C, 3, 4, 5, got 2. The right angle, and we got 1. All right, let me connect the dots here. Okay. So we got ABC, and we're trying to get DEF. All right, so if these are similar, then there's a series of rigid motions and dilations taking ABC to DEF. Now I know A and D correspond, so I'm going to translate A to D, and then I'm going to rotate 180 degrees. Okay. And then I'm going to dilate by a scale factor of 2 with center D. So we're going to dilate the 3, 4, 5 by a scale factor of 2, and then it will work. So yes. Yes. Because I was able to get triangle ABC to triangle DEF. The steps were translate by directed line segment, AD, 2, rotate, center D 180 degrees, and then the third was dilate, center D, triangle ABC, A prime, B prime, C prime, actually 2 primes, so I did 2 moves. So dilate center D, triangle ABC, double prime by a scale factor of 2. Cool. So because I was able to do these steps, there was a series of rigid motions and dilations taking one to the other. Switch sketches with your partner. Forget that. Find a sequence of rigid motions and dilations that would take. So just skip this one because this is going to be a video lesson. But what you would need to have done is found your partner's similar triangles, and you'll find that as long as they did what it asked in 1 and 2, you will have two similar triangles, so there will be a series of rigid motions and dilations taking ABC to DEF. Alright, that was 7.2. Okay, 7.3 is the invisible triangles. We're just gonna do this. We're gonna do three sets of what we just did. So series of rigid motions and dilations, getting ABC to DEF. So here's ABC, A, B, C, 1, 2, 3, 1, 2, 1. Okay, so we're gonna work on the series of motions, series of transformations, I should say. Going from ABC to DEF, that's the goal. And we're gonna use these sentence frames, but I'm gonna help you with them. So A, B, C to DEF. Okay, so I see automatically that there's a A-D relationship. They both have the 3 marks. So I'm gonna just translate A to D. So write down the steps, translate, and it's called a directed line segment, AD. And then 2 is dilate, center, D. Figure is A prime, B prime, C prime. And the scale factor is, well, we need a bigger scale factor. So we're gonna go DF divided by AC. DF divided by AC. That'll get us there. Okay, card B, here we go. Here's another ABC. A, B, C, C. And you want to make sure you get the numbers of annotations. Connect your dots. Another ABC to DEF. We got to figure out how to get there. They are really hammering home the setup for the angle similarity theorem, which you're going to learn about next. But here we go. All right, so here's a visual. I'm going to look for A and D. First move, translate. 2 points you know are going to match up. Okay, so then I got to go from, let me see here. I got to get this single over here, so I'm going to rotate. All right, there we are. Then I'm going to dilate the bigger one to the smaller one. And to do that, we're going to have to get a scale factor less than 1. So we're going to say DE over AB. Because smaller over bigger is going to be less than 1. All right, so here we go. Let's write these steps up here. So to go from the steps from triangle ABC to triangle DEF. Gonna underline that. 1, translate. AD. 2, rotate. Center D. Counterclockwise. So CCW, and then what we're doing is until AC and DF are on the same line. Until AC, A prime, C prime, and DF are on the same line. Okay, so we are here now. So now we're here. Now we're gonna dilate, third step. Dilate, center D. Figure is A double prime B double prime C double prime. Scale factor, again, we're right here. We gotta go smaller, right? We gotta dilate A prime, B prime, C prime, or A double prime, B double prime, C double prime. We gotta get it to D, E, F. So in order to do that, we need the scale factor. It can be represented by this, DE divided by AB. DE divided by AB, because that'll make it smaller. All right, one more. This may be the same triangle. Let's just triple check. Yeah, it is. Okay, cool. So A and D again. So we're gonna go translate AD. And then we gotta get this 1 over here. So why don't we rotate up here? Now the 1s are aligned, and then we're gonna reflect. And then we're gonna dilate. Oh, that's a lot. Okay, here we go. 1, translate via AD. 2. Do it right here. We're gonna rotate center D until A double prime C double prime lines up with DF. So A double prime C double prime aligns with DF. The figure was A prime B prime C prime. 3, we're reflecting over DF. And lastly, we are dilating center D, figure A triple prime B triple prime C triple prime, and the scale factor equals, so we are here. The scale factor, it's got to be bigger, so you go big over small. Scale factor is DE divided by AB. Oof, tough problem. All right. So you got to figure out 3 times how to get from ABC to DEF. That was invisible triangles. All right, now the summary. Let's talk about the summary. What you are learning with all this, all these shenanigans. So one figure is similar to another if there is a sequence of rigid motions and dilations. It takes the first figure so it exactly fits over the second. By the properties of dilations and rigid motions, similar figures have corresponding angles congruent. And pairs of corresponding side lengths in the same proportion. In the case of triangles, the converse of this statement is true as well. If a pair of triangles has all pairs of corresponding side lengths in the same proportion, and all pairs of corresponding angles congruent, then the triangles must be similar. Imagine any pair of triangles with all pairs of corresponding side lengths in the same proportion and all pairs of corresponding angles congruent. The same sequence of rigid motions and dilations will work to show that the triangles are similar. For example, triangle EFI was dilated using E as the center by the scale factor given by BC divided by EF. Because we wisely chose the scale factor this way, we know that side BC is congruent to side E prime F prime. We already know that all pairs of corresponding angles are congruent, which means we have enough information to use the angle side angle triangle congruence theorem to prove that E prime F prime I prime is congruent to triangle ABC. Okay, that means triangle ABC can be lined up exactly with a dilation of triangle EFI, which is the definition of similarity. It doesn't matter what the triangles look like or where we start, we can always define a dilation that made one pair of corresponding sides congruent and then use the angle side angle triangle congruence theorem to finish proving that there is a sequence of dilations and rigid motions that takes one triangle onto the other. All right, so what they said is they excuse me, they dilated EFI using E as the center and by the scale factor BC divided by EF, and then we were here. So then we're here. Because we wisely chose the scale factor this way, we now know that BC is congruent to E prime F prime. We already know that all pairs are congruent, so this and this are congruent. So A with E, sorry, A with E, A, B with F, right? Well, I'm blanking here. Anyway, yeah, that is, this one's 2, this one's 1, and this one's 3. So they already know all the angles are congruent. And now you have one side congruent, so we're good to go. I think there was a small typo there. But anyways, cool, lesson 7 down. Took about 30 minutes, and nice job. Tough lesson.